A parabola is a set of points such that each point is equidistant to a fixed point called the focus. So we have one focus this time. We've had two foci with ellipses and hyperbolas. We only have one focus when it comes to the parabola. A new thing with parabolas, we have this horizontal line called the directrix. We have a horizontal line called the directrix. So what's going on here, they're equidistant. So the distance from the focus to the point and the distance from the point to the directrix will always be equal. So it's got one drawn on there. Let me give you another example. If we pick this point on the parabola right here, the distance from the focus to that point and the distance from that point to the directrix, those distances are always equal. Parabolas, you've been doing parabolas since, some of you since the 8th grade. The only ones that we've really dealt with are the vertical ones, but it is possible for a parabola to be horizontal as well. So we're used to this. If it's vertical, the general form of that would be y equals x squared is your basic normal parabola, right? So if we turn that sideways, we're just changing our variables. It's going to be, the general form for that would be x is equal to y squared. You're more familiar with looking at it as the square root function. It's just the positive and the negative square root function. All right, so just like we've been doing with all of our other functions, we're going to talk about the distance from the focus to the vertex. We don't talk about this having a center. It has a vertex like we're used to. You always talked about a parabola having a vertex. The distance from the vertex to the focus is a distance of p, and this is the directrix. That distance is also p. And then your axis of symmetry goes right through the middle. And the axis of symmetry is always perpendicular to the directrix. Horizontal, same thing. We've got our vertex right here at the maximum / minimum. Obviously, this is not a maximum or minimum because it's left and right, but there's your focus, there's your P. This distance is also P. That is the directrix. It's just aligned in the other direction. And your axis of symmetry is, of course, through the middle. Just this time it's a horizontal axis of symmetry instead of a vertical axis of symmetry, just because of the shift in orientation. The focus is always inside of the parabola, just like it was with the hyperbolas. Okay, remember our curves with the hyperbolas, the foci were inside. The directrix is always outside. The directrix and axis of symmetry are perpendicular. And the vertex is, we'll call it absolute value of P because it is possible for that constant to be negative. It is absolute value P units away from the focus and the directrix. Okay, so kind of like our A's and B's and C's that we've been dealing with, well, with the parabola, we just use a P instead. So your standard form, it looks a little bit different than the way that you're used to parabolas looking up to this point. The vertex is at HK. The vertex is at HK, so similar to our centers. So x minus the h, y minus the k. You always write it so that the squared term is completely by itself. Any constants need to be on the other side. Same thing with the y. It would be y minus k squared is equal to 4p times x minus h This is always by itself. The constants are on the side with the variable that is not squared. Now, this part should make sense. It opens up if p is greater than 0. So if p is positive, your parabola is going to open up. If p is less than 0, aka negative, your parabola is going to be opening down. You're used to that. Left and right goes the same way. Positive would be right, negative would be left. Greater than 0 is right, less than 0 is left. All right, any questions about our equations, how they're set up, what they look like, etc., etc.? All right, so let's look at some examples of if we're trying to graph these things. Okay, let's look at number 6. Let's look at number 6. Here's our equation, -1/10 times y plus 2 squared minus 3 is equal to x. That is not in standard form. So standard form isolates the term that is squared, so we've got to do that one step at a time. First step is always adding and subtracting, if applicable. So we will add that 3 to the other side. And then we're going to multiply. We've got that fraction, -1/10. So to move that over, we multiply both sides by -10. So our standard form here is y plus 2 squared is equal to -10 times x plus 3. So now we're in standard form. We can identify our vertex. We can identify everything that we need to identify. So our vertex, change the signs. -3, -2. Make sure that you get the x and the y in the correct order. Now, this one is y squared, so this is opening left/right. So our axis of symmetry is going to be the y coordinate. Our axis of symmetry is going to be the y coordinate because we have a horizontal axis of symmetry. So y equals is horizontal. To figure out our focus and our directrix, we need to know what p is. So this number, the constant, is equal to 4p, is what our standard form equation says. So when we divide by 4, we reduce that, it's -5/2. So our focus is that many units away from our vertex. Now, let's put on our picture what we have so far. -3, -2 is our vertex. Our axis of symmetry is the y equals -2. So I plotted my vertex, and I'm drawing the dotted line for my axis of symmetry. The reason why I do that is because I need to kind of wrap my head around, okay, I have what p is. Do I add that to the x or do I add it to the y? Well, the focus is that many units away from the vertex and it's on the axis of symmetry. So we're going to add this to our x. And let's see here, it's negative, so we're going left. So that's going to put us at -5/2 is -2.5. So if we go left, -2.5 units, that's going to put us at -5.5, -2 for our focus. Our directrix is a line that is that many units away from the vertex. So we go 2.5 units to the right. And it is also a dotted line because it's not technically part of the graph. And that's a vertical line, so it's going to be x equals -0.5. So we can now graph this. From this point, you've just kind of given it a sketch, unless you want to plug in specific points to try and solve, just draw yourself in there a little parabola. All right. Let's look at an example where we need to complete the square. Let's look at number 8. Look at number 8. We have x squared plus 10x plus 4y plus 1 equals 0. First thing I want to identify for myself is, am I going to be vertical or am I going to be horizontal? It all has to do with which variable is squared. X is squared, so this is a vertical parabola. This is more of what we're used to. So that means I need to move everything else to the other side. So I'm going to subtract the 4y and subtract the 1. I'm just going to leave my x's on this side. I got to complete the square, so 10 divided by 2 is 5. 5 squared is 25, so I add 25 here. I got to keep my equation balanced, so I add 25 to the other side. So when we factor the left side, we get x plus 5 squared is equal to negative 4y plus 24. Still not quite in standard form yet, because standard form factors out that coefficient on the right side. So if we take out the negative 4, we get y minus 6. So our vertex, change the signs, negative 5, positive 6. Go ahead and plot it on your graph. Okay, our axis of symmetry, this is a vertical one, so the axis of symmetry is going to be a vertical line straight through that vertex. So it's x equals the x coordinate, because it goes right through, vertically through the vertex. For the focus and directrix, we got to find P. So negative 4 is equal to 4P. So that means P equals negative 1. If P is negative, it's going to open down. So that means our focus is 1 unit away. So it's 1 unit below our vertex. So negative 5, positive 5. It's going to be where our focus is. Our directrix is 1 unit above. Bless you, is a horizontal line. Y equals 1 unit above our vertex, so y equals 7. This one's going to be a wider parabola because our focus and directrix are so close to the vertex. So the closer they are, the wider your parabola is going to be. The further away they are, the more narrow you're going to be. Any questions about how I came up with any of that information? Okay, just like we've done with the other ones, let's go the other way. If we're given some information, let's go backwards. Okay, so let's just, so that we'll have it to reference, let's write our equation again. X minus h squared is equal to 4p y minus k. The horizontal, y minus k squared is equal to 4p times x minus h. And just as a reminder, p is the distance from the vertex to the focus and from the vertex to the directrix. So if we're given a graph, let's look at, these are pretty easy, we'll do a couple of them. Let's look at number 2. Okay, let's look at number 2 first. This is obviously a horizontal parabola. So we're looking at the second scenario. Let's identify our vertex. Let's see here. We're 1, 2, 3, -2. 3, -2 is our vertex. So let's just write down the shell of our equation here. Okay, I gotta figure out what h, k, and p are. So if I identify my vertex, I got h and k, right? H, k. So x minus 3, y plus 2. I got to figure out p. They drew the, or they put the focus on here, so I just count the units. 1, 2, 3, 4, 5 units away. So 4 times 5, or you can go ahead and write that as 20. It is opening to the left, so this needs to be a -20. All right, let's do one where we have the directrix. So number 4. And I misspoke a moment ago. I said that the closer they were, the wider it is. It's reversed. I'm sorry. The further away they are, the wider it is. The closer they are, the more narrow. Number 4, this is a vertical. So it's x is squared. The vertex is at -1, 2, 3, 4. -1, 2, 3, 4, 5. -4, -5. So x plus 4, y plus 5. Our directrix is 5, 6, 7, 8, 9, 10 units away. And this one's opening downward, so this needs to be negative as well. So it'll be -40 times y plus 5. So it's pretty simple when you're looking at the graph. So my suggestion is if they just give you information, put it on a graph. Okay, put it on a graph. So let's look at number 7. Number 7. They give us the vertex and the focus. They give us the vertex and the focus. So like I said, just draw yourself a quick, easy sketch of this. You don't have to be super accurate. Just give yourself a general idea. The vertex is at -7, +1, and the focus is at -7, 3/4. 3/4 is less than 1. The focus is always inside my parabola. So I'm going to go ahead and just sketch really quickly that that's what my parabola is going to look like. I know it's downward facing because the focus is below the vertex. It's vertical, so that's going to be x is squared. I can go ahead and plug in, they gave me the vertex, so I can go ahead and plug in x plus 7 and y minus 1. 1 minus 3/4 is 1/4. That's my p. Okay, that's the distance from the vertex to the focus. So that's 1/4. It is downward facing, so that is a -1/4. So if we rewrite this, I've got a little bit more room, so I'm going to rewrite it this time. 4 times -1/4 is just -1. So you may see it with a negative in front of the parentheses, or they may go ahead and distribute the negative. Either way, just recognize that they're equivalent. Questions? Let's look at the vertex and the directrix, same deal. Okay, you're just finding the distance like you did with the focus. Let's look at the more difficult, and it's still not that difficult, but it's just a little bit more involved. If they give us the focus and the directrix, they give us the focus and the directrix. So let's look at number 15. Again, I draw a picture. Okay, -8, 5 is our focus. So -8, +5 is our focus. Our directrix is at x equals +4. So this is at 4, this is at -8. The vertex is always going to be right in between those two. So it's going to be, what's between -8 and +4? -2. -2 would be right in the middle, and it's at the same height as your focus. So our vertex is -2, +5. So I just found directly between -8 and +4, add them, divide by 2. Okay, -8 plus 4 is -4, divided by 2 is -2. So that's where I got that -2 from. So that's my vertex. So now I can kind of draw in my picture. This is a horizontal. So go ahead and set up your skeleton. Y squared, 4 times our P. We can plug in our vertex. The X was -2, so it's X plus 2, Y minus 5. P is 6, actually -6, because it's facing to the left. Remember, P is the distance from the focus to the vertex, or from the vertex to the directrix, whichever way you want to look at it. It's a distance of 6, and it's towards the left. So that's going to be -24 times the X plus 2. So again, it's not really that much more difficult. It's just, I think it's easiest if you draw the picture, so you have something to look at and compare it to.